Okay. Okay, so hopefully you did 1.3, the quiz prep. And I told you, you should be able to do at least the first two, A and B, substitute a number into a function. The third one was substitute in an algebraic expression into a function and carry out whatever the algebra part of that function was. Now, here's what you're not going to learn. Brutal honesty. Your quizzes have been opened up. And I have pleaded with you about being legible. So I can read what you're writing, so I can give you the most points I could possibly find to give you. Well, it didn't mean much. To some, not everybody. Second, quizzes are open note. But you get these quiz preps, if you haven't tried them for yourself and you just show up hoping that what you watch and what you're going to have to do is just going to jive, and it doesn't, and so you've dug a hole for yourself. Because tests aren't open note. I don't care what your grades are. I don't give a shit. Are you learning something? And one of the things you have to learn more than anything else, if your strategy isn't working, then why continue with your strategy? If you're doing the same thing over and over and over and over again and the result doesn't change, you're not getting any better at something that you're trying to get better at, something that you hope will change your life, something will allow you to do whatever you want to be when you grow up or whatever. And what you're doing doesn't work, but you keep doing it anyway. That's the definition of insanity, according to Einstein. Repeating the same process, expecting a different outcome. I keep thinking eating ice cream at 2 o'clock in the morning is going to help me lose weight. It doesn't. That's my insanity. So, it doesn't get any easier. Again, this is honesty. And I notice that when most people come in, their first thing is, I'm going to sit in the back, which means I don't engage. That's not everybody. But it has always been a tendency especially in the co-rec. Last semester in the co-rec, there was less than 20. I took away the back row. Because what they were doing wasn't working. Now, did it help? I don't. All I knew is I had to try something. And if they weren't going to do it for themselves, I had to try to figure out what I can do. Sometimes I run out of ideas. I get old. You're going to get old too. Question is, are you going to get old with your goals met or not? And if getting a higher degree or whatever, achieving whatever you want to be or whatever, or just getting through this class or whatever, are they going to be met? And if they are going to be met, are you going to do it by changing what? If what you're doing isn't working, are you going to change it, or you can be honest with yourself? I don't want to lose anybody. I never want to lose a student. I'll do everything I can, but I don't know if you're going to tutoring. I don't know. I don't see a lot of you. I don't see many of you in office hours. I get a lot of trade people. One or two, maybe office hours. But everything's available. Tutoring's free. STEM Center. Okay. Now engage. That means you got to make yourself a part of your education. Here we go. I'm going to put up the answers. Nothing up my sleeves. Like you're supposed to know your times tables. 5 times 7, 35. 8 times 6, 48. Things you should be able to do without thinking about it. These problems you should be able to do without thinking about it. Doesn't mean you have to be able to do it without thinking about it, because you got to start somewhere. But the goal is to be able to do these things without thinking about it. The first 5 questions are right off the rules of exponents. So this one is just 12x. And this one is 5x to the third, and this one is negative 6x to the second, and this one is 40x to the fifth, and this one is equal to 12x to the fifth, and this one is equal to 2x plus 6, and this one is equal to negative 12x minus 20. And if there's a question you need to ask, don't just copy down what I wrote and think you're going to understand it, get it, figure it out, whatever. But if there's a question you need to ask, part of chapter 1 could be either the easiest part of chapter 1, or it's just going to be a whole. This is just substitution. You know, I say substitution on purpose, but one of these days that's what I'm always saying. I'll say it on purpose, and then I'll say, oh yeah, that's not substitution. Any question on the first 7? Number 8. X squared plus x. Number 9 is 12x squared minus 6x. Number 10 is 15x to the fourth plus 10x to the third minus 25x squared. Number 11 is x squared plus 7x plus 12. Number 12 is equal to x squared minus 7x plus 10. I'm not smart. Just ask anybody who knows me. I'm not smart. I'm not bright. I've done a lot of problems. I've done a ton of problems. I've tied my shoes a whole bunch of times. I know how to tie my shoes. But you know what? I haven't tied my shoes in 12 years, because it hurts my back to tie my shoes. So I just want to slip on. It's like, wow, it's a bad analogy at my age. I've kind of tied my shoes in a hole. You got me. Questions? Don't just accept what I've written Don't just copy down what I've written. If you didn't do it and you don't understand it, you need to ask, because this is going to be on your quiz and you got to show the work. I didn't show any work. Just writing down those answers is not going to get you credit. You're going to have to show the work on how we get here. That would not be enough on your take-home quiz on Monday. You don't show the work, you don't get points.
And you just multiply and throw it in the county. Whatever is outside of the planting seeds, like usually in the seeds.
Distribution, the distributed property. The distributed property says if you have A times a parentheses of B plus C, order of operations, you're supposed to do what's inside first, but they're not like terms. We still have to multiply, so we distribute A times the B, and then we distribute A times the positive C, so positive times that would be a positive A times the C. So on 10, 5x squared times a 3x squared plus a 2x minus a 5. Here's the analogy. Distribution is like me being a kid at my cousin's wedding and my mom telling me I got to dance with my tia Carmen, my tia Kika, and my tia Chencha, tia Cortez. Chencha. He was the weak one. So I would have to dance with tia Carmen, so 5x squared times the 3x squared. Then I got to dance with my tia Kika. Positive times a positive, that's positive. 5x squared times that 2x. And then Chencha's a negative. So we distribute. Positive times a negative is a negative. 5x squared times 5. So 5 times 3 is 15. It just turns into this kind of a problem. 5 times 3 is 15. X squared times x squared is x to the 4th. And then a plus. 5 times 2 is 10. X squared times x, that's x to the 3rd. A negative times a positive is a negative. 5 times 5 is 25. And I have an x squared. You cannot combine these together because they're not like terms. And then when you see something like number 11, that's my brother and me. That's my brother, and here's me. And we got to dance with Tia Carmen and Tia Kika. And so again, this is just distribution. Now, you may want to use the word FOIL, which is fine, but FOIL doesn't work when you have more than 2 terms and 2 terms. It's all just distribution. So we distribute. My brother has to dance with Tia Carmen, so x times x. And then he has to dance with Tia Kika, positive times a positive, so that's plus x times a 4. He has danced with both. Now it's my turn. I hope it's a short song. Positive 3 times positive x with the positive 3 times the x. And then positive 3 times positive 4, so that's positive 3 times 4. You don't have to write all that out. You can just multiply. But x times the x, this would just be an x squared. X times 4, that would just be a 4x. 3 times x, you just write 3x. And 3 times 4, you just write 12. Combine your like terms now. There's no other x squared terms. X to the first, we have 4x and 3x. 4 x's and 3x adds up to 7 x's. 7 evil x's. And then plus 12.
Yeah, you may. I feel like no, a way that I can do it. Like I'm just doing it. So like do it on the board.
No. Because you're going to do boxes?
Yeah, box.
You going to draw a box every single time?
Yeah.
You can do a 3x3?
Yeah. There's nothing wrong with the method or?
No, there's nothing wrong with the method, but there's something wrong with having to draw a box every single time. And I get why a box is nice because I've been how you're taught, and I like the rainbows. And sweet tooth, Skittle, and all that good stuff. But the bottom line is, we also have to be able to just look at it.
Yeah.
And I know I'm going to go x times x, so there's my x squared. I have a 4x and a 3x in the middle, it's 7x, and then 12. And when you have x to the third, and that's an x squared, if this is an x squared, that's an x, and the powers are different, you got to make sure you take into account those things. And if signs are messed up and things like that, there's a lot of things that can go wrong in a box. But boxes do have their purpose, and I don't want to give another method out there where it works for you. I won't mind.
Yeah, I got you.
Okay, 13. 13 gives us 3x squared and then plus x minus 4. This is x squared plus 10x plus 25. This is 9x squared minus 12x plus 4. And this is x squared minus 36. You can always use the word FOIL. And FOIL is great, again, when you have two terms and two terms, a binomial times a binomial. If you're not familiar with the word FOIL. This one right here, actually, let's do 13. 3x plus 4 times x minus 1. So I've used the analogy about making them dance, distribution. But that's what FOIL is. FOIL stands for, you multiply the first term times the first term. So 3x times 4 times x. The first term in the parentheses times the first term in that parenthesis. The O stands for outside times outside. The outside term times the outside term. Outside times outside. The outer terms. The outer terms is what's to the outer part of the parentheses, what's to the outer part of this parentheses. So the outside times outside would be this 3x times that negative 1. Take care of your sign. The positive times a negative, so it's going to be a negative. And then you have this 3x times that 1. I've taken care of the sign already. The I stands for inside times inside. So the inner terms, inside the inner part of the parentheses, the ones that are next to each other. The inside term times the inside term. That's a positive times a positive. That's a positive 4 times that x. And the L stands for last times last. The last term times the last term. So this last term was a 4, that last term was a negative 1. So a positive times a negative. Take care of your signs. It's going to be a negative, and you have a 4 times that 1. So first times first, outside times outside, inside times inside, last times last. So that's our 3x times x is 3x squared minus 3x times 1 is 3x. 4 times x is positive 4x, and then minus 1. Combine your like terms. There's no other x squareds. Negative 3x plus 4x is positive 1x, and then a minus 4. Okay? That's how you apply the word FOIL. And FOIL is great when it's a binomial. A binomial is two terms times two terms. But a binomial does not help. Sorry, the word FOIL does not help when I have x plus 3 times something like x squared minus 3x plus 9. Because if I try to do FOIL and I go first times first, outside times outside, inside times inside, and then last times last, nothing multiplied, nothing distributed to the negative 3x in the middle. And that's what's supposed to happen is you're supposed to distribute each one of these terms has to multiply with each one of those. So we just distribute. That's all it is. And then you combine by terms. So it'd be x times x squared. Let's just go straight to the answer. What is x times x squared? X to the third. A positive times a negative is going to be a negative. What's x times 3x?
Negative 3 squared.
Negative 3x to the second, or 3x squared. And then an x times positive 9 is going to be a positive
9x.
9x. So we distributed x to each term. And now we distribute the 3. Plus 3 times x squared, 3x squared. Positive times a negative, going to be a negative. What's 3 times 3x?
9x.
Minus 9x there. And then 3 times 9 plus 3 times 9 plus 27. Combine all your x to the third term. Well, there's only this one. A negative 3x squared. This is a positive 3x squared. What do they add up to?
0.
They cancel out. There is 0. Negative 3x squared, positive 3x squared. So negative 3 of those x squared, and then a positive 3 of those x squared. So they add up to 0. They have no x squared. And then a positive 9x and a negative 9x. What do they make?
0.
They make a 0. So all we have left is a plus 27. So this x plus 3 times x squared minus 3x plus 9, we can multiply this out, is x to the third plus 27. It doesn't look like it's going to be that way, but you're not supposed to just look at it and get it. Multiply it out, combine like terms, one step at a time. You're going to have to get the last 3, well, definitely the 14 and 15. Number 16, if you just multiply it out, distribute, you'll get there. But they're all special. 14, you don't just square each one. 14 has got a special case. It's a special product. 15 is a special product. They're perfect squares. 16 is a special product. Okay? If you notice, 14 is not x squared and then a 5 squared. It's not just x squared plus a 25. You don't just square each one. There's a 10x in the middle. This is not just a 3x squared and then a minus 2 squared. You don't just square each one. There's a negative 12x in the middle. And then if you look at this, you see how there's nothing in the middle? That's because the terms, The terms are exactly the same. That's an X, that's an X, that's a 6, that's a 6. But what's different is the sign. One's a negative, one's positive. So that's going to make 0 terms in the middle, 0x in the middle, and that's a special product. So you have, for multiplication, 3 special products. A plus B perfect square. So the sum of 2 things and you square it. When you multiply this out, you square the first one. A is going to be squared. In the middle, you multiply A times B and you double it. A times B twice. You have 2 of them. So you multiply A times B and then you double it in the middle. And the last term is the B squared. So that X plus 5 squared is exactly like A plus B squared. So the way this works is it's supposed to square the first one, and then you multiply the first and the last, and double it in the middle, and then the last thing is your last term squared. So I square the X, so X squared. In the middle, I have 2 times A times B, so that's 2 times X times the 5. 2 times AB, this is A, that's B, so 2 times X times 5, and then plus the B squared, plus 5 squared, X squared, 2 times X times 5 is 10X, and then 25. And so in the middle, we have this, so what I did 2 times X times 5, that's why I have 10X in the middle right here. Now, let me show you why with numbers, and then I'll show you how this actually works. If I gave you 3 plus 4, and I told you was square. Now, if you did this, if your answer was just X squared plus 25, but that's what you got, then you're assuming that you just square the X and you square the 5. And you don't have a middle. Okay? If that's your assumption, then this would be square the 3 plus square the 4. Because that's what you did here. So I'm going to square each one like this. So that means the answer would be 9 plus 16, so 25. But we know we're supposed to do order of operation. Inside the parentheses was 3 plus 4. 7. So then we can do 7 squared, which is 49. Does 49 equal 25? No. Which one is actually the correct answer? 49. 49. They can't both be right. Watch what happens if I apply the special product to 3 plus 4. To the A plus B squared equals A squared plus 2AB plus B squared method. So the first term is 3, so A is a 3 squared. Plus, you multiply 3 times 4 and double it, so that's 2 times the 3 times the 4, 2AB. And then the last term, 4, you're going to square it. And that gives us a 9 plus 2 times 3 is 6. 6 times 4, that's a 24. And then you have a 16.
What happened if the what were negative? What would
So let's not do the what. Let me finish this. Can I finish? Yeah. So we get 33 plus 16, which is 49. Doesn't matter if I'm using numbers, using variables, a plus b squared, a squared plus 2ab plus b squared. There's something in the middle. You don't just square each one. Now, will some of you still be doing this all the way through to the fund? Yeah. Will I keep telling you, don't do this? Yeah. Will you still keep doing it? Yeah. Is your strategy working? No. Will you change? That's up to you. Here's why. If you have x plus 5 squared and you don't know what to do, you don't have this memorized, you don't trust yourself to use this, okay? Just remember that x plus 5 squared is x plus 5 times itself. You don't have to use the special case. You don't have to use the special product. You can just distribute. X times x is x squared. X times positive 5 is a positive 5x. 5 times x is a positive 5x. 5 times 5 is the 25. X squared plus 10x plus 25. You don't have to use that special product. You can just expand it and multiply it out. So there's no reason to get it wrong. The only reason if you got it wrong would be because you're guessing. This is why it works. When you see this, you're supposed to multiply it times itself. So a times a squared. Positive times a positive, a times b is positive ab. And then b times a, that's another positive. Now, b times a is the same as a times b. Multiplication is commutative. So that's another ab. And then positive times positive, that's a positive b squared. You have a squared, 1ab plus 1ab, that's 2ab, and then a b squared. And that's how we get the special product. Not because we wanted to make the multiplication part of it incredibly difficult, but because that's what it equals. That's what happens when you square something like that. And if it was minus a minus b perfect square, it's exactly the same term. You have an a squared, you have a 2ab, and you have a b squared. The only difference is in the middle, if this is subtraction, this is subtraction. This is going to be positive no matter what. Because when I do a minus b perfect square, that's an a squared, the same thing. This is 2ab, same thing. That's a b squared, those are the same thing. The only difference, this is minus instead of plus. So that's subtraction, that's a minus, and this is still going to be a positive. Because when you multiply that out, you're going to get a times a, so you get that a squared. Positive a times negative b, that's a negative ab there. Negative b times a, that's a negative ab there. Negative b times negative b, that's a positive b squared. So in the middle, negative 1ab, negative 1ab is negative 2 in the middle. So it's just that sign. Okay. These special products You don't have to use them. You have to be able to multiply whatever you have out. You don't have to use them. And remember, you gotta show the work. Whether you multiply it out or you use special product, you gotta show that work. All right, come on back at 10 and we will start with the quiz prep questions.